My domain here? What's my domain?
Negative infinity.
Negative infinity to positive infinity. It's all real numbers. Or you can put all real numbers, right? Whichever one you want to put. Okay. Find the x and y intercepts. Show your work. So what's up with the x-intercept? X-intercept, what's going on with the x-intercept? Oh, which one do you do first? X or y? I don't care. Pick one.
X.
X, okay. X-intercept. What's up with the x-intercept? You need to set what? Set something equal to 0. What is saying equal to 0? The y or the x?
Y.
The y. We set the other one equal to 0. So here's my function. I'm going to make y. Is f of x my x or my y? That's my y. So I'm going to set that equal to 0. Everyone do it. 0, write it in. Put it in, write this function, but put y in for 0 and for y.
Does it matter?
And then solve it.
Does it matter if you remove this first or on the end, or you
Yeah, you gotta
cube
take care.
it?
You gotta.
Okay, you don't cube it
Otherwise,
first.
no, because you have to cube this with it.
Oh, okay.
So you'd be doing
yeah.
this times that, and it's a giant mess.
That's what I was doing, but I just wanted to
Right.
make sure. 'Cause I was thinking about order operations and I got messed up.
Right. Okay, so everybody should have written down 0 equals cube root of x minus 1 plus 2. Okay, so then Eric said, well, can we cube both sides? Here's the problem. If you cube both sides, if I did this, that would end up being this. Oops, sorry. Times this. Don't write it down. Don't write this down. Times this. So it means I'd have to FOIL. I'd have to take this times that, this times that, this times that, this times that, and then that, whatever I got from that, I have to multiply all those by each of these two as well. So I end up with something crazy like cube root of x minus 1 to the second power times 4 plus, cube root of x minus 1. I would not get rid of the cube root, basically. So that would be bad. So do not do that. Thank you. That's a great question. I'm very, very glad you asked that. So we can talk about this. You can't, if you cube root this without it being by itself, you will get a giant nightmare. That's the bottom line. You'll become messier. You won't be simplifying it, you'll be messifying it. Does that make sense?
Mm-hmm.
So get it by itself first. So when you cube root it, you just cube root that. Does everyone understand what I'm saying? Mm-hmm. Okay. So how do we need to? So everybody get the cube root by itself. Do whatever you need to get the cube root by itself. So what's with the cube root? This plus 2. You got to get rid of that. So everyone get rid of that. Do whatever you need to do to get rid of this. Right? You need to get this by itself. Yeah. Andrew? Mm-hmm. Yeah, and that's still on. That's good. Okay, so you go ahead and do it. Okay, so I think everybody's doing this. Draw my little line for success. So if you can just help me kind of check and make sure everybody's doing whatever they need to be doing. So I get negative 2 equals cube root of x minus 1. This looks really familiar. Very close, very awesome. Okay, so everybody's at least here?
Yes.
Okay, so then we need to, now we have it by itself. What do you do to both sides? You undo the cube root. So everyone undo the cube root. Do whatever you need to do that. I think everybody's.
Oh, yeah, this one, I don't know if I'm going the right way, but we'll see.
We'll be there in a minute.
Yeah.
Perfect. Okay, so yes, we're moving too slow for folks. We will move right along. Sorry. So here we're going to cube both sides. Right. And we end up with -8 equals x minus 1. How do you undo the -1? You add 1 to both sides. And we end up with our final answer. Sorry, you add 1 to both sides by then. It's a mess. So you end up with -7 equals x. So my point is going to be -7, comma 0. So make sure you have that. That's the final answer.
Did I go wrong somewhere?
Right. Oh, no, I'm sorry.
This is the next one, but-
Oh, yeah. Y 0. Good. Now the next one, this one is the y-intercept,
Yeah, so you got -2.
which means we're going to set
To get rid of-
x equal to 0.
And then-
So we're gonna write a function again, only we're gonna put in 0 for x and then solve.
And then I divided, and I ended up with this.
Oh, there's no dividing.
Uh,
Okay, so this one, we're gonna set x equal to 0.
Well, I'll
So-
probably mess up somewhere.
Y equals the cube root of 0 minus 1 plus 2. Is this what everybody has down? Good? All right, then find the cube root of 0 minus 1.
Figure it
0 minus 1 is just minus 1. Draw my little lower dead center. What's the cube root of -1? What multiplied by itself 3 times gives you -1? -1. And combine those two, and you get y equals 1. Great, so y is 1, so our point's going to be 0, comma 1.
So, when you're solving this one, you keep everything on the right, you don't do anything on the left side?
Okay, so here's the thing. Here, we're trying to figure out what x is. We only have one variable.
Yeah.
So the point is, here, we're trying to solve for y. Do you see what I'm saying? So here I'm trying to solve for y. I don't need to do anything. Y is already by itself. So all I'm doing is simplifying this. We're not adding anything. We're not adding -2 to both sides.
Oh.
We're just trying to clean up what we have already.
Oh, because you don't need to minus -2.
No, because there's nothing I'm trying to simplify. I'm not trying to get, here I'm trying to get x by itself.
Okay.
So when we do something to both sides, so we're trying to get x by itself.
Oh,
We're trying to get this guy all alone.
okay,
We already have this by itself. It's already there.
okay.
So all we need to do is figure out what does this mean,
Okay.
right? So what is the square root of -1? What is the cube root of -1? What is the, this part here?
Mhm.
And we already have y by itself. Here, we had to do all this stuff because we needed to get the x. We needed to unravel and get the x
Okay.
alone. We had to undo what was happening to x.
Yeah.
Here, y is already by itself.
Okay, that makes a lot of sense.
Yeah. Okay, so we have those 2 points. What was it? It was -7, 0 and 0, 1. So now we're going to do a few more. X, Y, -7, 0, and 0, 1. We have those two. I think for this that's actually probably enough. So I'm going to draw in my function. X needs to go at least to -7 and 0 and 0, 1. So I need to make sure I go at least to -7. That's fine. I can probably go right in here. Draw my line. Should be all right. All right. So -7, 0. Where's -7, 0? 1, 2, 3. First you go to the elevator, then you go up or down. So for my origin, I'll go to the elevator, -7, and then I go up or down 0 floors. I'm right here on the ground floor. Next one, 0, 1. There's that one. Really? Did we do these? Did I do these right? Or not?
Yeah, but that's the only 2 points we have, so
Oh,
I think we should
Is
get
this
some more
the
points.
S shape?
this is the S shape. Oh, you're so right.
So do we use the other points?
So then we need some more points. Okay, so let me find the transformations. So let's figure out what the transformations are. So how has this been transformed? Let's ask ourselves this one. How has it been transformed? X minus 1 plus 2.
So we have to start with the origin point,
X.
because it shifted.
So how has this been transformed? We said it was,
Right 1, up 2.
yeah, everyone figure out the transformations. Ignore what Eric said and find the transformations for yourselves. So on the inside, is the inside my left, right, or my up, down? Left, right. So the inside is -1. So everyone write down what that is. -1 on the inside. Remember, that's the opposite. So -1 means what? Write it down. Write it down. Under transformations, right? -1 on the inside means what? What transformation is that? It's left, right. Which one is it? And then on the outside is +2. On the outside, is that left, right, or up, down?
Up, down.
Up, down. So I'm going to write out the transformation for +2 on the outside. What's that? Write it down in here. So the outside is up, down, so it's going to be up 2. You said it's going to be -1 on the inside means right 1. Because remember, that's the opposite. The inside's the opposite for the transformations. Okay. So my new center is going to be from my 0, 0. This is my old center. I'm going to go right 1, up 2. Here's my new center, right there. Does everyone see it?
Mhm.
So from here, I can do my points from there. Let's go and pop that one in. Let's pop that into our line. So that's 1, 2. All right, here's my another XY. Boom, we have that one. And then, what's up with my S shape? From my center, I go back 1, down 1, back 8, down 2. What about the other way? So remember, get out your Bible. And get out your the very first sheet that we did. So remember that one? The very front page of the very first sheet.
7, 8, shoot. Okay.
All right, this one right here. Radical functions and their graphs. And how do you folks all write in the points that go in here? Yes? No? Natalia's got it out.
So we.
So then, it's a cube root, so it's the one on the left. Remember, this is going to tell us how to do all the other points. There's 5 points. You have your center. Then from your center, you go back 1, down 1, back 8, down 2. From your center, you go right 1, up 1, right 8, up 2. That's how you get your S. Yeah? And for the square root, that's the, for percent you go right 1 up 1, right 4 up 2, right 9 up 3. This is your Bible right here, this sheet. Yeah.
So are we filling
No.
these points and then
Oh yeah.
those?
We're filling those points into here. Yep. So it's going to be right 1 up 1, right 8 up 2. And that's my S. Good. Don't touch this one. This is our origin. That's open circle. I was just pointing that out. Okay. So what are my other points then? Let's see. I have at least one other one I can write in here, which is 2, 3. It looks like.
2, 3.
Yep. I won't write the last one. That's not a big deal. Okay.
So 9,
Sketch the
4.
graph. Oh, identify the range. What's up with my range for the S function?
Negative infinity, positive infinity.
Yep, all real numbers, negative infinity to positive infinity. All right, so the S's are easy, because all the S's, the cube roots, are always going to be, range and domain are always going to be all real numbers, right? Negative infinity to positive infinity. Now let's take a look at the next one. The one on the back. Hold on. Oh, we have an inverse. I'm sorry. Where are we?
We're on number 2, the next page. 5 of 6.
We didn't do the inverse. Oh no, I'm on the wrong handout. No wonder. I'm like, that doesn't look right. Okay. There we go. Okay, good. Perfect. So yes, let's look at number 2 on the next page. And the back one we're going to skip. Right, we're going to skip number 3.
So the whole thing.
Yeah, the whole thing. Oh no, it's raining. No, it's not. Yeah, it is. What is going on with this weather? And I was in Southern California all weekend. It was nice and sunny down there. What the heck? Okay. Set the domain and range. Okay, domain and range. What do you folks think? Is this, am I dividing by an x? Something with x in it? No, I'm not dividing by anything with x in it. Am I square rooting an x? Something with x in it? I'm getting 1 yes and 1 no. Everyone think about it. Am I square rooting something with x in it?
Yeah.
Don't say it out loud.
Square root.
I would take 15 seconds on your own. Am I square rooting something with x in it? Check with your neighbor. Okay, so I have a square root. Inside the square root, there's an x. Everybody see that? So now we have to do a rule. What's our rule? So the first rule is you can never, ever, ever divide by, you can never, ever, ever what? Divide by 0. Everyone say it. You can never, ever, ever divide by 0. Okay, what's the first thing? What's the other thing? You can never, ever, ever square root a negative number. Is everyone on board with that? You can never square root a negative number. So what do I know about the inside of this? X plus 2 has to be what? Check with your neighbors. X plus 2 has to be what? If you're not talking to your neighbor, I will call on you. Better check with other neighbors then. Okay. You can never, ever, ever what? Take the... You can never, ever, ever...
Square root of a
negative number.
Square root a negative number. Okay, so I want to say it. You can never square root a negative number, which means that what's inside can never, ever, ever be what?
Negative.
A negative. It can never be negative, which means it has to be, if it can't be negative, it has to be what? Positive or 0. So whatever's inside has to be what? Positive or equal to 0. So how do we write what's inside has to be, how do we write has to be positive or
Greater
greater than
or equal to.
or equal to 0? Yes. So we got nice. Perfect. Greater than or equal to 0. Does that make sense for folks? What's inside has to be greater than or equal to 0. It has to be positive or 0.
Is this true always?
Always.
Yeah, okay, so it's always
Always.
just gonna be automatically,
Automatically.
X's, we don't even have to think about
Square
all
root,
those.
yeah, cube root could be anything.
Yeah,
But square root, or fourth root and even root, we're not going to deal with fourth roots in this class, but even roots, square root, fourth root, sixth root, it has to be greater than or equal to 0. It cannot be negative. Everyone on board? Okay. So, Eric, so if your kids ever have a thing where I have a thick square root negative and they have to have this I thing, that's an imaginary number. So if you do it, it's not a real number. It's imaginary, right? It doesn't exist in the real world. Okay, so here, can never, ever, ever be negative, so it has to be greater than or equal to 0. So let's figure out what does that mean for our domain. If x has to be greater than, x plus 2 has to be greater than or equal to 0, solve for x. X has to be what? Everybody do it. Yeah.
Are you leaving the 3 out like on purpose or?
Yeah, because we don't care about up or down. We only care about the domain. What can x, right? And the domain only cares about, we're also leaving out the square root part. All we're saying is what's inside of the square root has to be greater than or equal to 0. So we're not solving the equation. What we're saying is what's our restrictions on x? And x cannot make the inside negative. So it makes sense for folks? So we're not solving the problem. We're not substituting anything into the original equation. All we're saying is, what can x not be? And x can't be something that makes the square root negative. So we start saying, well, what can x not be? Does that make sense for folks? That's all we're doing right now, is sorting our domain, what x can and can't be.
so can I clarify something?
Yeah, please.
So on a cube root, I guess the,
Domain range is all real numbers. It can be
all real
anything.
numbers always.
Always.
And then on the square root, it's always gonna be 0, infinity.
Right, okay, so my cube root
Okay.
looks like this, right?
Right,
My square root looks like that,
okay,
which means that it starts off here, it only goes, from here it only goes from here to the right, and from here up. So it has a domain and range restriction. Does that make sense? It's not going to be all real numbers.
right.
It never goes. So what do we do to both sides to get our x by itself?
Subtract 2.
Subtract 2.
Oh, we have to-
Well, because I need to get the x by itself. There's something going on with the x. It's not by itself. I need the x by itself. So I want him by himself. He's not by himself. I need to get rid of whatever's next to him. So that's my domain. X has to be greater than or equal to -2. Or you could say, if you want to do it in interval notation, it has to be greater than or equal to -2. So -2 to infinity, but remember it can be equal to -2, so I'm going to make that into a square bracket. All right, so what I want you folks to do now is find the x and y intercepts. We've done 3 of them together. 2 of them together? 2 or 3 of them together? Do one on your own.